Welcome back to the 25th part of Debugging at Scale, where we understand the subtle nature of metadata when logging. When our applications fail in production, we usually reach for the application log. It's our first line of defense. If it isn't enough, we will need to reproduce the problem in some way, and that isn't trivial. While logging does receive a lot of tooling attention and appreciation, the practice and standardization around it is lacking. Most companies don't have a best practices guide or any significant standardization around it. Logging is the very definition of debugging ahead of time. We write the log before there's a bug, and then rely on it to point us in the right direction. If we could, we'd log everything. Unfortunately, that's a disaster waiting to happen. A recent Reddit thread described a situation where a new project spent 100,000 USD on Azure logging ingestion costs over the span of a few days. Notice that this would have probably affected AWS or GCP just the same. This was just a sample of too much logging, creating an unreasonable bill. Overlogging is a major problem. The cost of logging in production environments is often estimated at roughly 1/3 of the total cloud costs. That's a tremendous amount to spend on a problem that might not happen. This doesn't account for the performance overhead incurred due to logging. That can cascade into significant additional costs overall. Cutting down on logging is a double-edged sword. If we run into a production issue and a log is missing, then we have no way of tracking down the issue. There are multiple attempts at working around this issue, such as log levels. There are good ideas, but the standardization around them is too general. To make matters worse, developers don't apply standardization uniformly, even within the same project. This is one of the things that bothers me a lot. Every established company I've ever worked at had a coding style guide. Very few had a similar document that discussed how we should log. This is insane. Logging is far more important than code formatting. It actually impacts production and code quality. If you don't have a document like that, you should start working on one right away. Following are some tips about the content. When I talk about creating a new standard, I have to include this XKCD. Otherwise, they take away my speaking license. All loggers suck. I know. Writing a new one is trivial, but for the love of God, don't do that. Don't do an abstraction on top of the logger. That's an abstraction on top of an abstraction. Third-party libraries won't use it. So what's the point? Just use the logger. People sometimes write a lot in the log messages. This hurts readability and adds costs to the ingestion. Keep the log to the point, as you can see in the bottom sample. There's no reason to tell a story. Logs must be unique. Use search and see if there's a log that's even similar in the code. If there is, it might cause a problem in 2 a.m. when you're reviewing a log and looking at the wrong line. I want to be clear here. Even if a log looks slightly similar, there's room for confusion. Make a change so one of the logs will look noticeably different. Logs and loops are both verbose and a performance hit in terms of raw performance. You might think your loop doesn't go too high, but things might change and blow up your log. This is generally a bad idea. Even if the log isn't printed, it still takes up some CPU, and this can be very expensive in a loop. A list or an array can grow. Even if it's small right now, you can easily blow up the log with unreadable data. This is almost as bad as logging in a loop. Don't invoke code to perform a log. A simple example is this. I invoke a method to fetch additional data. This might have low overhead right now and might be read-only right now, but with project changes, the method might have more overhead and might even change application state in subtle ways. Logs must never impact state, even if you can turn them off. You don't want a case where something only works with logs turned on. If the state isn't physically here, then it isn't relevant. One of the workarounds is callback interfaces. If a log is filtered out, the callback interface isn't invoked, which produces less overhead. But that's still bad. We can still impact performance when the log is included. It can still change the state and outcome when the log is enabled, so we're just hiding the problem. I strongly suggest avoiding this. I see people logging the time or the current thread when both of these are usually printed for every log line. If you have MDC, then you might have additional metadata that you shouldn't log. This is just wasteful and confusing. I suggest having one log line per method at most. Don't have a log in trivial methods like getters and setters, possibly a bit more in huge methods. This is obviously open to debate and there are exceptions, but too many logs in a method will make combing through the logs difficult. If we have one point to place the log, where should we put it? Right before the return, so we can include the return value as part of the log. When you analyze a log, the return value from the method is often some of the most valuable information there is. Of all things I speak about here, the exit versus entry logging is the most controversial. The return value is remarkably valuable, but it's also valuable to know if the method was reached when inspecting the logs, and there are cases where we don't have that. However, quite often we do have a stack trace to go with the error, and it does solve the problem of reachability. In that case, the more complete method state along the way can help paint a more complete picture. It's not just the return value, it's the full set of calculations and method logic. This implies an even bigger change. We need to write code that doesn't immediately return a value, but instead stores it in a variable so we can log it. This doesn't look pretty. Developers reject that on looks alone. But if you give it a try, you'll love it. In a debugger, we can place a breakpoint and easily see the value. If we get an exception stack trace, the line numbers will map more clearly. This might be more verbose, but it includes the logging, so it makes sense. It's easier to debug, that's for sure. I have a lot to say about logging and decided to split it into multiple videos to keep this watchable. In the next part, we'll continue the discussion of best practices and MDC. If you have any questions, please use the Slack channel to ask them. Thank you.